Okay, welcome back. So, in this section, our goal is to continue with the basic signal operations that are performed on discrete time signals. Now, in the earlier classes, we said the basic operations that we perform on these discrete time signals can be classified into two categories depending upon whether the operations are performed on the dependent variable or independent variable. Independent variable, which is time, and here the dependent variable is simply denoted by x of n. So in the earlier classes we discussed how we perform how the various basic operations are performed on this discrete time signal, which are based on this dependent variable. In this video and next few videos, our goal is to concentrate on basic signal operations, basic signal operations which are which actually manipulate the signal characteristics by acting on the independent time variable. Independent time variable. So in these operations, we manipulate the signal characteristic by simply acting on the independent time variable or variables which are used to represent this signal. This simply means instead of performing operations like addition, subtraction, and multiplication between signals, multiplication between different signals, we perform operations on the independent variable. Means we are performing, instead of these operations, we'll perform the operations on independent variable and see how the signal characteristics change as we perform the operations on the independent variable or variables that is termed as n in our case, right? So in short, our goal is to study how do we manipulate the time variable n. How do we manipulate the time variable n in the next few basic signal processing operations. Our goal is to see how do we manipulate this independent time variable. Independent time variable. So that's our goal in next few videos. All right, so the first basic signal processing operation that is performed on this independent variable is called time shifting operation. Time shifting operation. See, as the name suggests, this simply means we are shifting the time by some amount. Now, what is meant by shifting the time by some amount means simply if we have a sequence x of n, and if we shift this independent variable means n by some amount, let's say k units of time. Now k is either a positive integer or a negative integer. See, in the first lecture, I said that n, we will restrict our n, means this small n to be, will take only independent, and will take only integer values for this course. So we'll restrict n this to be an integer value. So k must be an integer value. So if we shift this signal, it's our sequence. For example, k can take values like 1, 2, 3, or it can take values like -1, -2, 3, 3, and so on. So these are the values taken by this k. So accordingly, our goal is to see if we put k plus or minus, whether the signal will be shifted to the right are left, or when do we call this signal a time delay signal, and when do we call this time shifting operation a time advance operation. Let's learn that. To illustrate this, let's take a very simple example to illustrate this time shifting operation, and to see when do we call this time shifting operation a time delay operation, or this time advance operation. Let's learn that. Time advance or time delay operation. When do you say that a shifting operation is a time delay or time advance operation? To illustrate this, let me take an example. Let me take a very simple example. Let's suppose mix of n is, let's suppose 1, 2, 3, 2, 1. And let's suppose this is my n equal to 0 point. Right. So if we plot this sequence, this looks something like this. X of n will look something like this. So this is x of n. This is my x of n. So and the value of sequence at n equal to 0 is 3. So when n is 0, the sequence value of the sequence is 3. The value of this sequence when n is equal to 1 is 2. Similarly, the value of this sequence when n is equal to 2 is 1, and the rest of the samples are 0. Similarly, the values of the sequence for negative values of n are 2 when n is minus 1. Similarly, value of this sequence is 1 when n is minus 2, and the rest of the samples are 0. All right, so this is our x of n. Now to illustrate this time shifting operation, let me take value of k equal to first equal to b plus 1. So my sequence will be x of n minus 1. And to illustrate it, let me say that the resultant sequence we name as y of n. So let's see what is my y of n. All right. So to calculate the values of y of n for different values of n, what I'm going to do, I'm going to simply write it here. So y of n when n is equal to 0, that is simply as x of n minus 1. N is n minus 1, put n equal to 0. This will give us 0 minus 1, that is simply x of minus 1. And value of x of minus 1 is 2, that you can check from here. So value of x of minus 1 is 2. Similarly, value of y of n when n is equal to 1 will be x of n minus 1 when n is equal to 1. This will simply give us 1 minus 1, which is x of 0, and x of 0 is 3, that you can check from here. Similarly, value of y when n is equal to 2, which is same as y of 2. Y of 2 means x of n minus 1 when n is 2, because y of n is defined as x of n minus 1. So this will be simply x of 2 minus 1, which is x of 2 minus 1 is 1. So this is x of 1. X of 1 is 2. So value of my sequence is 2. All right. Similarly, value of y when n is equal to 3. So this is y of 3. Y of 3 means x of n minus 1 when n becomes equal to 3. So this will be x of 3 minus 1, which is same as x of 2. X of 2 is 1 from here. All right. So this is 1. Now, now the rest of the samples of y means y of 4, y of 5, and so on are all zeros. The rest of the samples of y are all zeros. Okay, now let's calculate y when n is negative. So y of n when n is minus 1 will be equal to y of minus 1, which is same as x of n minus 1 when n is minus 1. So this will be x of minus 1 minus 1. X of minus 1 minus 1 is simply x of minus 2. X of minus 2 is from the given sequence is equal to 1. So this is equal to 1. Now the rest of samples of y for negative values of n means y of minus 2, y of minus 3, y of minus 2, y of minus 3, and so on. Y of minus 4, y of minus 5 are all zeros that you can confirm from the given sequence. Substituting the values and repeating the procedure, you will get these values equal to be 0. So our y sequence, which is equal to x of n minus 1, is like this. So my sequence here is what's my sequence? 1, 2, 3, 2, 1. So this is my y sequence, and my origin is here. So y of 0 is 2, right? Y of 0 is 2, y of 1 is 3, y of 2 is 3, y of 3 is 1, and so on. And y of minus 1 is 1. And rest of the samples are 0. So this is my signal when k was equal to 1, means when we put k equal to 1. Now let's put k equal to minus 1. So we obtain a sequence that is y of n plus 1, because, okay, let me rewrite this. I have a sequence which is x of n minus k, and this time I'm going to substitute for k. I'm going to substitute for minus 1. So this is simply x of n plus 1. So this is my sequence. And let's name this sequence as y of n. For convenience, let's do this. Let's name this sequence as y of n. Now let's obtain the values of y of n, or let me use a different name this time, z of n. Instead of y of n, let me name it as z of n. And later on we can do the comparison between x and y and zn. Okay, so let's calculate the value of z of n for different values of z. So always start with n equal to 0 point. So n is equal to 0, that means simply z of 0, z of n is defined as x of n plus 1 from here. So this will be simply when n is equal to 0, so this is x of 1. So where z of 0 is same as x of 1. What's the value of x of 1? X of 1 is 2. X of 1 is 2. Similarly, z of n when n is 1, that is same as z of 1, which is x of n plus 1 when n is 1. This is same as x of 1 plus 1, which is x of 2, and x of 2 is 1, that you can confirm from the original signal. Now similarly, z of n when n is equal to 2 will be equal to z of 2, which is x of n plus 1 when n is 2. So this is 2 plus 1, 2 plus 1 means x of 3, x of 3 is 0, and you can repeat this procedure. You will get values of z for n equal to 4, for n equal to 5, n equal to 3. Let me rub this. This is this. So this is z of 3, z of 4, and so on. These samples are equal to 0. Now let's compute the values of z when n is negative, when n is minus 1. So this will be z of minus 1. Z of minus 1 is same as x of n plus 1 when n is minus 1. So this is x of minus 1 plus 1. And this is x of 0. X of 0 is 3 from the given sequence. You can check it. So z of n when n is equal to minus 2, which is same as z of minus 2. This is same as x of n plus 1 when n is equal to minus 2. So this means minus 2 plus 1, which is same as x of minus 1. And x of minus 1 is 2. Similarly, z of n when n is equal to minus 3, this is same as z of minus 3. Minus 3. Now, all right. Okay. This is x of n plus 1 when n is equal to minus 3. This is same as minus 3 plus 1. This is x of minus 2. X of minus 2 is 1. And the other samples of z, meaning when n is equal to minus 4, n is equal to minus 5, and so on. These samples will be equal to 0, that you can check repeating this procedure. You can get these values as equal to 0. So our sequence Zn sequence will be same 1, 2, 3, 2, 1. But this time the origin is at here. Means my origin, my n equal to 0 point is at 2. Right. Okay, this is our sequence. Now I'm going to write these sequences again for comparison. So my x of n is 1, 2, 3, 1, sorry, 2, 1. And my y of n, which is same as x of n minus 1, is equal to 1, to, sorry, origin head point is this. And this is my origin point, and z of n. Z of n is defined as x of n plus 1. So my sequence is 1, 2, 3, sorry, not 4, but 2. So this is 2, this is 2, 1, but the origin is this point. All right. So let's compare these sequences, but using by plotting these three sequences. Let's compare these three sequences by plotting these three. So this is my x of n with respect to n. This is my y of n, and this is same as x of n minus 1. So, and next sequence is z of n, which is same as x of n plus 1. So let me draw the values now. First, at n equal to 0, value of the sequence is 3. Value of the sequence at n equal to 2, n equal to 1 is 2. At n equal to 1, n equal to 2, the value is 1, and the rest of the samples are 0. Similarly, values of the signal for negative values of n, this is 2, and this is minus 2, the value is 1, value at minus 3 is 0. Now values of y of n, which is same as x of n minus 1, the value of this signal at n equal to 0 is 2. So at n equal to 0, value of the signal is 2. Value of the signal at n equal to 1 is 3. Let me redraw this axis. So this is the value at n equal to 2, and value of the signal at n equal to 2 is 2. Value of the sequence at n equal to 3 is 1, and at n equal to 4, the value of the sequence is 0. Similarly, the value of the sequence at n equal to, sorry, this is 1. Now the value of this sequence at n equal to minus 1 is 1. Now similarly, values of x n plus 1, which is same as zn. Let me clear this axis first and redraw the axis. So this will be my n axis. So values of the signal are let me redraw this again. Values of this for making the comparison. So this is x of n plus 1, and the values of the signal are 2 when n is equal to 0, and the value of the sequence is at 1 is equal to at n equal to 1 is 1, and the value of the sequence at n equal to 2 is 0. Value of the signal at n equal to minus 1 is 3. Value of the sequence at n equal to 2 is at n equal to minus 2 is 2, and value of the sequence at n equal to minus 3 is 1. So these are our sequence. Okay. See, this is our original sequence, and these are the shifted versions of the same sequence. All right. So which one should we call time delayed version, and which one should we call time advanced version? Means for which value of k we should call this a time delayed version, and for which value of this K we should call this time advanced value. All right, so let's concentrate on n equal to 0 point. Let's to compare the sequences. Let's compare the values at n equal to 0 point. All right, so let me first compare x of n. Check the value of x of n at n equal to 0. See, the value of sequence at n equal to 0 is 3. That's this much. The same sample point arrives in x of n minus 1 when n is equal to 1. So in other words, this sample comes later in x of n minus 1. So you can pick up from this that this is actually a delayed version of this sequence. So this x of n minus 1 gets something like a delayed, because the sample point which is at n equal to 0 in this comes at time when n is equal to 1. So this comes sometime later in time. So this is a time delayed version of this. So when n k is positive, this is the time delay operation. Time delay operation. All right. Similarly, let's compare the values of x of n and x of n plus 1. Now you can make the comparison of x of n and x of n minus 1 for the rest of the values. You will get the same answer. Now let me concentrate on x of n and x of n plus 1 now. See the same sample. Let me compare the same sample, means x of the value at n equal to 0 of x of n arrived earlier, means at n equal to minus 1 in x of this. You can check it. So when k is negative, the sample value arrives earlier in time, means in x of n plus 1 sequence, it comes earlier as compared to the sequence x of n. So this is a time advance operation. So this is a time advance operation of this sequence. So x of n plus 1 is actually a time advance operation of x of n. So you can say this is time advance operation of x of n. You can compare the rest of the samples, you will get the same answer. So this is a time advance operation, this is a delayed operation. So when k is positive, this becomes a time delay operation. When k is negative, this becomes a time advance operation. Now let's see, if it is time delay, will it be shifted to the right or left? Let's check that also. See, when the x of n minus 1 means in which k is positive, and this is a time delay operation that we just confirmed. Now the same sequence means x of n minus 1. See, it gets shifted to the right. You can check it. So this is a shift right. So this is a right shift operation. So this is a right shift operation. You can check it. So the signal gets shifted to the right. So you can say time delay operation is same as shifting the signal to the right. Now this time, by how much we shifted the sequence to the right? That's the next question. We see if we are not using the unit of time here, the unit of time can be anything. It can be 1 millisecond, it can be 1 microsecond, it can be 1 second, it can be 1 minute, it can be 1 hour, it can be 1 day. That depending upon the unit of time. We are not bothered about the unit of time, but we say 1 unit of time. See, the sequence x of n minus 1 is shifted to the right by 1 sample. How will you confirm that it is shifted to the right by 1 sample? Check again the value of this x of n when n is equal to 0. You can check on this that the sequence, that the same value arrives at n equal to 1 point, means it gets shifted to the right by 1 unit. So this is a time delay operation by 1 unit of time. Sorry, let me use a different marker. So this is a time delay operation of 1 unit of time. Now let's concentrate on this sequence x of n plus 1. So see that this x of n plus 1, we said that this is a time advance operation, and this sample comes earlier in time, and you can see the sample value gets shifted to the left. So left shift operation is same as time advance operation of a sequence. So left shift operation is same as time advance operation, that you can confirm from the sample point or using any other sample point. And that's why I took this example. This explains this beautifully, because I am using this sample point which is equal to 3 to compare the sequences. And the same thing you can confirm from this, that this is a left shift operation by how much time? By 1 unit of time. So this is a 1 shift unit of time to the left. Now let me repeat the same. X of n minus 1 is a time delay operation of x of n, and the sequence gets shifted to the right, and it gets shifted by how much unit of time? By 1 unit of time. Similarly, x of n plus 1 is a time advance operation of the sequence x of n, and the sequence, if you concentrate on the sequence, it gets shifted to the left by how much time? By 1 unit of time. All right, now in general, so if I now tell you, if I say give me x of n minus 2, so what would you say? You can draw this very easily, this sequence very easily. You can say that this is a time delay operation by how much? By 2 units of time. So you will shift this each sample by 2 units of time to the right. Similarly, if I say x of n plus 2, this means a time advance operation, and time advance by how much? By 2 units of time. In other words, shift this signal each sample point by 2 units of time, means the sample point in x of n which occurred at n equal to 0 will now occur at, means the sample point which occur at n equal to 0 in x of n will now occur at x of minus 2 in x of n plus 2. Remember that. So this shift is the sequence to the left by 2 units of time. And in general, you can say x of n minus k is a shifting operation. And whether k is positive, this is a right shift operation. If k is negative, this is a left shift operation. And time advance or time delay operation, I hope that's clear, because it simply means by how much time the signal will come delayed, or the sample point will come delayed or advanced in time. That's why we say this is a time delay operation or time advanced operation. I hope this is clear to you guys. Now the applications of this time delay operation in digital signal processing or discrete time signal processing. What are the applications of this operation? Now remember, this time delay operation is a very important operation in many signal processing applications. For example, time delay version of a signal is used when performing the autocorrelation operation. We use the delayed version of the sequence and do the comparison of the signal with itself, means with x of n the sequence, then we delay the sequence by some amount of time and check the correlation between that, and this is called referred as autocorrelation operation, which is a very important signal processing operation. For example, in radar signal analysis and other signal processing areas, in image processing and other signal processing. Now, another field that involves the concept of this time delay is the artificial intelligence. Another field that involves time delay operation is artificial intelligence. Artificial intelligence. Now, such a system, if such a system uses this time delay operation, and this operation is involved in time delay neural networks, means this operation means time delayed neural networks is used in artificial intelligence. Okay, this is it. Now in the next class we shall study about folding operation.